Hey guys, so this video is to help you with the lesson Ice Lab if you were not here in class today. Okay, so it's a very simple experiment. So right here I have a beaker with 20 milliliters of a clear solution in it, and we're going to add ice to that solution. Okay, and then we're going to observe that solution for a few minutes. Okay, so I'll probably try and set up the camera to try and view it. We'll see what we can make work. Okay, but before we do, it's good to always make a prediction first. So I would pause the video and make a prediction as to what you think will happen. Now, as always, predictions don't need to be correct, they just need to be yours, okay, as I always tell you guys. So pause the video, make a prediction, what will happen with the ice in the water. All right. So we're going to take a couple of ice cubes. Now, normally kids make predictions like the ice is going to melt, which is a fair prediction. I mean, our last lab we did was boiling water. So we're talking about phases of matter and phase changes, so boiling water, melting ice, that's fine. But we end up having a discussion. In that discussion, I asked how many people think that this solution is water. And some kids will think that it is, you know, because we're dealing with ice. They think that's normal. Some kids won't because they tend not to trust me, which I guess that's a learned trait, that I'm trying to pull the wool over your eyes. But to know that it is water or not, we talk about how we could know that. And we end up saying, well, ice floats in water. And so if it's water, then the ice will float. Well, let's give it a shot and see what happens. Okay, so let me hold this here where y'all can see it. Put a couple of pieces of ice, and you can see right there already this ice does not float. Okay, it sinks there in the water. Okay, and I've got enough pieces there. That piece is sticking up. There we go. Okay, position the camera a little bit better. You see the ice is not floating, so you need to draw a picture. Draw a picture of this with the ice in the bottom and then the liquid above. Okay, then for the next few minutes, you need to observe what happens to this ice. Okay, so I'm gonna leave it just like that. That'll give me a chance to step away. Okay, you're gonna make observations. So you'll make observations, explain why you think those observations are happening, and you're going to ask questions about this phenomenon that's going on right now. Okay, so give it a few minutes to observe the ice in the solution that's not water. Let's maybe we're going to set this behind it, maybe. Give you a black background, maybe. That's not going to work. Okay, never mind. That's not going to work. Okay, I'll be back. All right, so now if we look at this, we can see that our ice is no longer on the bottom of the container. It started to float here in the middle, okay? So you need to draw a picture of that for slide 3 of the ice there in the middle with a layer of solution below it and above it, okay? You also need to explain why you think that ice is floating, okay? As we mentioned earlier, we actually talked about ice floating on something. What did we say it would float on? So then it asks for the 4 layers. There are 4 layers of solution going on in here, and we are counting the ice as one of the layers, okay? So what are our 4 layers? Okay, make sure you include that. Then in class, we talked about density a little bit. Let me move this camera. There we go. It's a little bit better. So in class, we talked about density a little bit and how density plays a part in different phases of matter. Which ones are the most dense, which are the least dense, how it plays a part in this solution as well. Okay, obviously the most dense solution is the one here at the bottom. Okay, as many of you should have guessed by now, that's liquid water from the ice melting. As the ice melted into liquid water, it's down here, and we know that ice floats on liquid water. So we have liquid water, then our ice, then our unknown solution. What's our 4th one? That's right, it's the air above that unknown solution. Okay, now for the sake of time, because this is getting to be a longer video already, that unknown solution is alcohol. Okay, some good old isopropyl rubbing alcohol. Okay, so those are your 4 things. The most dense in this being the water, least dense being the air at the top. Okay, when talking about states of matter, solids are the most dense and gases the least dense. Okay, because they're the most spread out. Density is mass per volume, or how spread out that mass is. Okay, if you have any questions, shoot me an email and I would be happy to answer them.